Hello and welcome. This is attempt 2 because I kind of messed up a little bit. Built this thing actually 1.5 years ago, this big coil. And I kind of messed up the calculations, so I have to do it all over again. Sadly enough, I don't have any glass fiber fabric tubes and things like that left, or hoses or whatever you call them. So I have to do it a little ghetto style. So I calculated the right coils, hand formed them out of plumbing stuff, which is also not ideal, but it will work, at least for the demonstration. So now I will nest them into each other and kind of fix them with I think I will use some cotton fabric. So let's start. I cannot show you much about me doing this because I don't have a tripod or so, and it would be a mess. So I will show you step by step. Another thing, I'm kind of sure that the electric part works, if a little inefficient, but because I had this coil running before, and the only problem was that the insulation is too thin, and I got basically boiling cooling water and things like that. So we'll go between something between this and this, because this is a little big, and I messed up the calculations. I thought it would work, but I have to go a little smaller. But anyway, so the electric part, I don't think that's a problem because this thing worked before. I actually got some semi success with it. I did some tries. It was well, let's focus on this. Yeah, you can see didn't fill up the mold. It was a little cold because I had to prematurely stop the melting because of the boiling of the cooling water. So yeah, anyway, so I hope this is not too crappy. I'll get a tripod and things like that if I'm in the mood to do more. Anyway, so I managed to find an old bed sheet that I could rip into strips, and I'm now basically weaving those coils together. As you can see, it's nothing special, just to keep them in form and make them a rigid piece. So I could put insulation in there and hold the crucible and things like that. So I finished the coil. Looks kind of usable. But before I do anything else, I will now temporarily assemble that thing and try if it starts the oscillator and if it works electrically, because that was a problem last time. The small one worked, and this one just didn't start it. I think it was because of me doing a bad error, and this is too big of an inductor. Anyway, so now I have those 3 coils nested into each other, or whatever you may call it, and stabilized just with some cotton fabric. It should work. It's kind of improvised, but the good materials, yeah, I wasted. So anyway. So let's give it a try. So I've now installed the improvised coil, and hope it's not too shaky. And you can maybe see 3 of those 0 voltage drivers, big power supply, relay, cooling, things like that. So now we will try. It starts up. Let's start the power supply and start the thing. Oh, seems to work so far. Let's see if it's inducing. Let's see a graphite crucible. Oh yeah, seems to work fine. Oh, it's already getting warm. Okay, so now I have to put the insulation in and the cooling and things like that, but I think I've solved the electrical problem, so now I will add some insulation and some cooling. So now I try to get all those ends, have a little overhang here so that I can put tubes on. And I managed to get everything at least that much of overhang to put the tube on. PVC tube for the cooling. It will be quite difficult to get them in. So what I will try to do is put them over a piece of pipe to widen them a little bit and let them stay there for a while, and then pull them off quickly and quickly try to get them over there and before they contract again. Maybe I put them outside to get them cold so that they hold the form a little longer. Makes it much easier to get them over the copper tubing. So I'll try to get it all in. I think I'll have to make some kind of manifold because I have to connect 1 to 3 basically, because I only have one pump. Oh, we will see. So I'm late now. I made those brass pieces, just a hole from one side, and now I will put 3 holes from the sides in there like a star, and yeah, 1 tube goes in and 3 goes out and vice versa, so I have manifolds that I can connect those 3 coils to the water pump. I think we'll just mill it, and this is quite messy. I really have to clean up, but there's a milling attachment on it, and I'll just take the round nose and mill and go in there. Thought I would center drill it and drill it, but then I found this 10mm round nose cheap end mill. Should be fine for brass. Well, anyway, I'll show you the finished parts. So the thing is now more or less finished. It's not that equally spaced, but should work. We'll now solder some copper tubes in there and we're ready to go. Also, I see that the battery is nearly dead, so I should recharge the camera while I'm doing that. Anyway, show you the finished thing. So I made those 2 manifolds or adapters or whatever. They're a little longer than necessary because initially I thought I would make those 3 tubes in line in one side, but then I thought it would be better for water distribution to make it as symmetric as possible, so that it turned out a little long. Anyway, they should work. So I will now install the cooling system and then the insulation and some support for the coil, and hopefully then we can have a test run. So I've now installed all the PVC tubes for the cooling, and I will now make a test. Just put the pump on there, get a bucket full of water and test for leakage, and then the final step will be put some ceramic fiber insulation in there and build some kind of support. I just wanted to test the cooling system, but unfortunately I ruined the pump because I had it connected to that whole thing while testing, and it ran dry and yeah, destroyed itself. So yeah, stupid me. Anyway, I will get a new pump. The fastest one on Amazon, shouldn't be much, 20-30 bucks. So here I have the new one, the pump that just arrived, and well, now we'll remove that old thing and replace it and test the plumbing or whatever you want to call it, tubing for leakage. So I just put the hose on. I had to heat it up a little bit to make it soft, but now it seems to fit. So the pump is running now. So far I cannot see any leakage. I will let that run for a while and then go through every joint and see if there's any leakage before I connect the electric power again. So I found some wood. By the way, the pump is still running. 2 hours now and still not leaking, so I will build a support, put the insulation in, and we'll just use a cotton fabric and kind of fix it with that, and then maybe I use some epoxy or something like that. We'll see. So I made myself a improvised needle for sewing, and then to get the strips through there. It's quite tight right now and I wouldn't be able to do it just with my fingers. So the first leg is attached now. I will now go on with the other two, and worked actually better than expected with that small little needle. But maybe I have to anneal it. It gets quite hard because I bend it all the time. But yeah. By the way, to remove the hook that's there from the second wire, basically, I just bend it a little bit, hold it against the belt center and bend it back, and now it's perfectly smooth. So the 3 legs are on there. Now put the insulation in. But first I have to put in some wood that connects those, to have something to prevent the whole insulation from just going through. I mean, it wouldn't directly go through, especially the material on the sides will have enough grip here, but I also have to put 2 or 3 layers of that fiber, the ceramic fiber stuff, below the crucible, and it aside of the top part where the flange goes on will hold all the weight, so to kind of support that down there. So I will put wood between them for compression strings, and then I will go on with the cotton fiber and combine that so that I have tensional strength and fix it to that, basically. Yeah, you will see how it turns out. I've now wrapped some of the cotton fiber straps around that and clamped wood between the studs and the legs, and now I will go with another cotton fiber strip around like so to fix that together, to give it some strength, and put some wood glue on. Well, there's the finished support structure for the insulation. So I've put the insulation in. I will now put a temporary lid on there and do a test run. You can see, yeah. I think I will do it like this every time I measure the temperature, so that you can get a feeling for the speed it heats up. So yeah, final test run, and if it turns out successful, I will make it kind of more permanent. I will get a small tongue for or plier for those cable ties, those with a long nose, that where you can tighten them and cut them to get them all around the ends of the PVC tubes, and strap them a little harder against the copper tubes. So just to fix it, it's a little more secure, that it didn't come loose, or don't come loose. So there we go. Put the lid on and we will see. Okay, we'll measure the temperature now, because I had it on for a few seconds. It's 84, 85 C something. Yeah, something around 80. So we'll now and it is 12:54. Let's start. Put a temporary lid on, because I'm on kind of realistic conditions, and turn it on. So I will take a measurement in, let's see, at 13:00. So in about 6 minutes I will take a measurement, and we will see how hot we will get. We'll basically measure every 5 minutes until it flattens out, or I reach 1300 C, which is the limit of my infrared thermometer. So we'll see. 1300. I'll take a measurement. Oh, it's already kind of hot. 506 C. Okay. Put the lid back on. So 506 C after roughly 6 minutes. Okay. Let's wait for the next 5. 13.5. Take the next measurement. Oh, and it's already glowing. So we're at 722. 1310. And I will now use this thing to remove that. Whoa. And get a measurement. So we're at around 900, 899. Starts getting toasty. By the way, some other measurements. The small coils get quite toasty on those circuit boards, 130, 140 C. The cooling water is at 30, 28, 29. So far everything looks good. I have to build some kind of conduit or guide for the air, so that those two coils get a little more. The coils down here from the other circuit only reach 70, 80 C, which is okay. They get a little toasty here, so they need a little more active cooling. You can see 140. The coils, not the rest. those two transistors have big heat sinks and they get enough air, and yeah, I'm only worried a little bit about those capacitors getting too hot, but anyway. Let's wait till the next measurement. So 1315. We're at 1036. As I mentioned, it's a little thin. It's only one layer, the rest is two, but it's only temporary, and I will fabricate a proper lid after that test, which so far looks kind of successful. I mean, we were over 1000 C and it took about 20 minutes. Sounds usable. 1320. $1,169 something. Yeah. So, yeah, I think we will reach the desired temperatures. Anyway, let's wait another 5 minutes. 1322. Well, it's hard to get a measurement like that. I think I got 1200 something. I mean, it's rapidly cooling now that the lid is off, so looks like we will be able to reach that temperature. Let's wait another 5 minutes and see. It could be already been to 1300, but the thermometer is kind of hard to use. I mean, it says max, but it doesn't go to max. That is average. Okay, the max is down here. So I'm a little dumb using that thing. Let's wait till 1330 and try it again. Maybe I will see when I watch the video that I will already at 1300. I don't know. So we're close to 1330, and this time I will put the camera away to get a quicker measurement. So I think I got a measurement. The maximum is at, not sure if you can see that, there, the lower row, the small numbers, 1247. I think that is enough. I mean, this thing is not that accurate, and it only goes to 1300, so I think I will stop now to not burn the crucible with no need. I mean, it's a nice incandescent light source, but I just burn it with no purpose isn't a good thing. So I will stop now, call that a success. Reached 1250 C, which is enough for the most bronzes and things like that, within about a half an hour, which is also good. And the next step will be to make a permanent lid and improve the cooling a little bit, the airflow here, and yeah, basically finish this thing up. So let's switch it off. And yeah, so this was a video about the induction furnace, and next time I will use this to cast some metal. But so far the furnace part is not done, but I basically figured out how to, and now make it a little permanent. I will use some refractory cement to bind the fibers and things like that and make it a little more permanent. So yeah, thank you for watching, and thank you for waiting so long for that video, and you see me hopefully in the next one. Forgot to tell you something. You should remove the crucible. That's a pure graphite crucible, by the way. Those are not vulnerable to heat shocking, so you want to remove it and cool it down as quick as possible, and air, not quench it or something like that. Then it may even cause some shock damage. But you want to get it out and cool it in air as fast as possible, because in there it will stay hot enough to burn for much longer time, and this is just ceramic fiber stuff, the air will go through. So just a tip. So now I will basically put that on here. Yeah, got it. And basically let it cool down in air faster. Oh look, the insulation is still glowing. So this way it will cool down much faster. It will burn a little more initially, but you can see it's going down. And the crucible will last longer if you do it that way. Don't worry about heat shocking those graphite crucibles, those pure graphite things. Anything else, those ceramic bound graphite or so, you don't want to shock them, but those things you can shock like that. And you should, because if you cool them down slowly, they will burn much more and get used up faster. So just a little addition. Anyway, now, well, that's really the end of the video.